let's learn how to use a new unit that's extremely important in chemistry. And that unit is called the mole. 1 mole is simply equal to this many particles, 6.0221421 times 10 to the 23rd. And this number is named after the person who came up with this, so this is called Avogadro's number. The reason we have this odd unit is because there are so many atoms contained in common things. If we tried to name how many atoms were in each sample we have, the number is so big that it's very cumbersome. So just like in the metric system, we sometimes use prefixes like kilo or mega or giga so that we can say these numbers more easily. What we do is we present it in a different unit. Instead of specifying how many atoms we have, we specify how many moles. And that's usually a much smaller, more reasonable number. We have 2 moles of this, and that's equal to something on the macroscopic scale. So this number is just more convenient because there are so many atoms in common macroscopic objects. The mole is also a generic unit, just like a dozen. You can have a dozen muffins, a dozen eggs, a dozen kittens, doesn't matter. You could do the same thing for moles. You could have a mole of kittens. You would just have a whole lot of kittens, as you can see. So moles, you can use it for anything. We're going to start learning it for atoms, but in the next chapter we use it for molecules, and we're going to see that it's not any different. It's just a way of counting things. That's it. So for atoms, what we also like to speak of is what we call the molar mass, which is just if you have 1 mole of an element, what's its mass? And it turns out this is a really convenient number for us. This number is listed on the periodic table. So for instance, if we take hydrogen, it has the number above it, that's its atomic number, and don't forget that tells you the number of protons. And then it has a number underneath it. So for hydrogen, 1.008. So this, as we learned earlier in the chapter, is the atomic mass, but it turns out it's also the molar mass. So that's the reason we have this particular number. It's kind of a weird number, but it's so the atomic mass and the molar mass will end up being the same thing. So the atomic mass is, oh, you can't read that at all. The atomic mass is the weight of 1 atom in units of AMU, whereas the molar mass is the mass of 1 mole, and it's in units of grams per mole. So it's the same number, but atomic mass refers to 1 atom and has its units. Molar mass refers to 1 mole and has its unit. But they're both equal to that number on the bottom of each box on the periodic table. So we say, okay, now I know these units. I know what a mole is. I can relate it to the number of atoms, or I can relate it to the number of grams. So not surprisingly, what we want to do with it are conversions. So now if we know how many atoms we start with of any element, we can figure out how many moles that is, and then we can figure out how many grams that is. To go for between atoms and moles, you use Avogadro's number, 1 mole, and we usually cut off Avogadro after the second 2, so 1 mole is equal to 6.022 times 10 to the 23rd atoms. Notice we could also go from moles to atoms, right? So these arrows are interchangeable, and we would again use the same Avogadro's number, except this time we would just flip it. So we're just going to have to think about how our units cancel out. On the other hand, you can also go between moles and grams now, and this time you're using the molar mass. So notice I have a question mark there. That's because this depends on the element. You have to get this from the periodic table. So for every element, that conversion factor between moles and grams is going to be a little different, but we're going to use it the exact same way. So now we should be able to go all the way from atoms to grams, or we could go backwards, go from grams to atoms, or we could just do a piece in between, go between moles and grams, go between moles and atoms, something like that. So we just need to remember this path, atoms, moles, grams. Notice that moles always goes in the middle, and think about what things we want to go between. So let's look at a few examples. We'll start with really simple examples. And I'm just going to make a little note to myself here that we want to remember it always goes atoms to moles to grams. So we can think about where we're starting and where we're going to end up. How many helium atoms are in 2.3 moles of helium? So we know the path is atoms, moles, grams. So we're going to start in atoms, and we want to end up in moles. So we want to go from atoms, nope, what am I doing? We're going to start in moles, and we want to end up in atoms. So we're not going to use grams at all. Don't try and use grams. So really think about what you're starting with and where you're ending up so you don't use numbers that you don't need. So anytime we go between moles and atoms, we can use the conversion factor. 1 mole is equal to 6.022 times 10 to the 23rd atoms. So we say, okay, I'm given 2.3 mole. I'm going to set up a conversion. I'm going to do this the exact same way we've been doing conversions. I'm going to put mole on the bottom, and that means I can put atoms on top. And 1 mole is equal to 6.022 times 10 to the 23rd. Some more room there. So my moles cancel, and I end up with the units I wanted, which were atoms. And I just punch this into my calculator, and I find out this is equal to 1.4 times 10 to the 24th atoms. That's it. We just use it as a conversion factor. Let's try another one. How many moles are contained in 5.5 grams of neon? So this time, if we think about our atoms, moles, grams, this time we're starting in grams, and we want to end in moles. So we're going from grams to moles. That means we're not going to use atoms at all. If we're not using atoms, you are not going to use Avogadro's number. That's the only time we use that 6.022 times 10 to the 23rd. If you're going between grams and moles, that's when you use the molar mass. So the first thing we want to do is look up neon in the periodic table and look at the number right below his box. So the molar mass of neon is 20.18, and we need to remember that that implies units of grams per mole. Molar mass is always in grams per mole. So that's what we're going to do. Now we can do our conversion. We have 5.5 grams. Grams must go on the bottom, and so that means my moles must go on top. So if I look back over here, the 20.18 goes with the grams, and a 1 goes with the moles. So notice no matter your conversion factor, it's always 1 mole is equal to some number of something else, either grams or atoms. So now my grams will cancel, and I'll end up with my moles, and I just punch that guy into my calculator, and I find out this is equal to 0.27 moles of neon. Just a simple conversion factor. All right, let's do the last one. I'm going to make some more room here. So again, we'll keep in mind my atoms to moles to grams. When we go between atom and moles, that's when we use the 1 mole is equal to 6.022 times 10 to the 23rd. When we go between moles and grams, that's when we use the molar mass. So we can just keep a note of that so we can remember that. And the last one, what is the mass in grams of this many lead atoms? So this time we're trying to go all the way. We're starting in atoms, and we're going to end in grams. Since we're starting in atoms, we're definitely going to use the 1 mole is equal to 6.022 times 10 to the 23rd. And because we want to end up in grams, we're also going to need the molar mass. So again, we need to look it up for lead. We always get this from the periodic table. And for lead, that is going to be 207.2, and the units are always grams per mole, like that. Now it's just a conversion. We're going to start with this. We'll start with the 5.56 times 10 to the 22 lead atoms. So in the next one, we know atoms have to go on the bottom, and moles are always in the middle, so moles will go on top. So we look back and we say, okay, this is where I'm going to use Avogadro. 1 mole is equal to 6.022 times 10 to the 23rd atoms. All right, kind of out of room here, but all right, let's rewrite this. I'm sorry. So we started with my 5.56 times 10 to the 22 atoms. We put our atoms on the bottom. and moles have to go on top. So 1 mole is equal to 6.022 times 10 to the 23rd atoms. Then we just do a second step because we're going atoms to moles to grams. Now we put my moles on bottom, we can put my grams on top, moles went in the middle. And when we looked it up for lead, my molar mass was 207.2 grams per mole. So the 207.2 goes with the grams, and the 1 mole goes on the bottom. So now my atoms cancel, my moles cancel, I end up with grams as my unit. So I punch this guy into my calculator, and I find that this is going to be equal to 19.1 grams of lead. That's it. So we're always just figuring out where we're starting and where we're ending up on a path like this. You can make your atoms cancel, make your moles cancel, that's all you got to do. The other thing is to keep in mind when you're going from atoms to moles, that's when you use Avogadro's number. So that's when you pull out the 1 mole is equal to 6.022 times 10 to the 23rd atoms. When you're going between moles and grams, that's when you use a molar mass, which you have to get from the periodic table. So this one is going to be different for every single element. The way we set it up is the same, but the number is different. We just got to look that guy up on the periodic table.